In this video, we're going to go over custom VIs in SoundCheck 15. Custom VIs will allow users to create their own code written in LabVIEW to be called by SoundCheck. For every custom VI, you will need a custom step in the SoundCheck editor and to place the custom VIs in the SoundCheck System Custom VIs folder. Each of these VIs will consist of two separate VI files, which are LabVIEW source code files. One is the editor, and one is the run VI. The editor VI is what runs when you double-click on the step inside of SoundCheck, and the run VI runs when you actually run the sequence and apply the step. One custom step is required for each custom VI you write. These VIs must be written in the same version of LabVIEW as SoundCheck. The bitness must also match. So if we're using a 64-bit SoundCheck, for example, we'll need to use a 64-bit version of LabVIEW to write our VIs. The LabVIEW version can be found in the README file of every SoundCheck release. A custom VI could be used to talk to an instrument and read a serial number for it and store that serial number in SoundCheck, to talk to an external device such as a turntable, or to make a measurement completely outside of SoundCheck and bring that result back into the memory list. In SoundCheck 15 and prior, input and outputs conform exactly to the editor run VI inputs and outputs used in SoundCheck. Anytime when SoundCheck's internal format was changed, in a newer release for example, that change was also required to be made to that custom VI. Now let's take a look at writing a SoundCheck 15 custom VI. We're using SoundCheck 15 64-bit, so we'll be using LabVIEW 2014 64-bit. This will just be a very simple VI that outputs a curve, value, result, and waveform to the memory list. The first step when making a new VI will be to open your SoundCheck installation folder, go to System, Custom VIs, and copy your step name here.vi and your step name here editor.vi. Rename them to whatever you want. One will always be the full name, and one will be the full name plus editor. So in this example, it'll be memlistoutputs.vi and memlistoutputs.editor. These stock VIs that are included in SoundCheck come as read-only, so you'll also need to select your copied VIs and remove the read-only attribute from them. So now we'll go to LabVIEW 2014 64-bit and open these two VIs. So here's what the standard template we give to users looks like. This is the code for the editor. There's a lot of code here that shouldn't be touched and is just needed to communicate with SoundCheck. In this case structure, only frames 7 and 8 will need to be edited, everything else should be left alone. Panel 7 is populating the front panel controls that the user will actually use when they open the editor. So here's the parameters A, B, and C we saw in the editor, reflected directly onto the control panel. If you want to add or remove anything, you can do that in here. But for now we're going to leave these alone because we don't need any inputs for this specific VI we're writing. We're just going to be outputting some constants, so we don't need any input from the operator side. If you're writing a VI for use, you'd probably want to hide these if you were just doing an output, but for now we'll ignore them. So now we'll take a look at frame 8. Here, we take everything that was input on the front panel and package it in a cluster, but again, we're not using these right now, so we'll just kind of move this out of the way. Up here at the top is the example code for outputting items to the memory list. This one here to the left is for creating a curve. Here we'll just change the name to custom curve. Underneath, there's a boolean called single value. This is how we differentiate between a curve and a value in the memory list. Right now, single value is false, so it will not be a value, it will be a curve. We also want it to create a value, so we'll make this a little bit bigger and copy all of the code. We'll rewire everything here, and we just change the single value from false to true, and change the name to custom value. So we'll expand this to give two elements to our array and wire in the value as well as the curve. Another thing we wanted is the waveform. By default, that example code is disabled, so we'll just need to enable the subdiagram to make sure we actually output the waveform. Now that this is enabled, we'll change the name to custom waveform. Now when saving this, we get an error. This means that we forgot to remove the read-only attribute, so let's go ahead and do that now. So now those are no longer read-only, and we can save. That took care of curves, values, and waveforms. Now we need to output the result. We do not include the example code stub for that, so you'll need to write it yourself. We'll click Select a VI, go to the SoundCheck folder, and there's an LLB called Custom and SC Run Sequence Sub VIs x64. Once we select that LLB, you can see all of the code that we include in it. To output results, you'll need to select unflatten results.vi. Then we'll need a bundle node on a cluster. And we'll change the name to custom result. We need to again open a VI from that LLB. And here we'll select flatten results. We'll wire these up, expand this array node, and include our custom result. So what all of this is doing is creating the placeholders in the memory list for these items. The next step will be to open the run VI and actually add the values to be output to these placeholders. Before we do that, let's take a look at what we already wrote in SoundCheck. We'll open up a new sequence and then save it as memListOutputTest. This is actually already here, so let's just overwrite it. Over here in the sequence editor under Step Templates, there's a custom step field. Each custom VI has a one-to-one mapping to the custom step. We'll right-click on the sequence editor on the custom step and select New. This needs to be the exact name of our VI. So here we need to enter memListOutput. Now it appears here in the sequence editor, and we can drag it into the sequence like we can any other step. We'll open up the memory list, and you can see it is still empty. To populate these placeholders, we'll need to double-click, open the memory list output editor, and then simply close it again. The editor code that was just written in LabVIEW will run and populate the memory list with those placeholders. Now you'll see a custom curve, value, result, and waveform appear in the memory list. This is the template for the Run VI. There's a lot of inputs over here on the side that should just be ignored. Over here, there's some examples of how to read data from the memory list. Down here is code that takes everything that was input by the front panel, unpackages it, and gives us access to use these parameters, A, B, or C, into our code. Here in the middle is where you want to put the code you actually want to run. And on the right is where we output data to the memory list. All of these names will need to be adjusted to match exactly what we had in the editor. So here our single value boolean is false, which again means that this is a curve, not a single value. So we'll change our name from curve name to custom curve. This will actually output the data to the placeholder we created in the editor. Here we're going to output an array of XYZ values. So this is the XYZ pair, and we'll just put in integers here. So 1, 2, 3, go to the next XYZ pair, enter 4, 5, 6, and then once more, and enter 7, 8, 9. Over here we can enter 1 and 0 to change between log and linear for the axes, and then select our actual units down here, and then what the dB reference is for those units. We'll just leave these as is for now, but if you wanted to make any changes to the curve, this is where you could make those changes. To create a value, just like the editor, we need to extend this area, copy the curve code, rewire everything here, and then change the single value boolean to true. We'll need to change our name again to custom value. We'll clear out the array and add in new numbers. For this one, we'll put in 1, 2, 3. The structure of a value is the same as a curve, except it can only have one x, y, and z coordinate. We'll expand this and wire these together to an array, and then move on to the waveforms. We'll need to start here by enabling the code and changing our name to custom waveform. Here is where we enter x0, dx, and the y data. x0 is time point 0, dx is 1 millisecond, and then we'll need to actually provide the y data. We'll create a for loop here and have values from 0 to 99. Change it to floating point so it can contain decimals. To make it compatible with our waveform, we'll need to add in a new data value reference. We'll delete this code and then connect our y data. So this waveform will start at 0 seconds and then count 0 to 99 at 1 millisecond intervals. The last thing we'll need to do is output our result. You need to enable this and then change the name again to custom result. And we'll just make our verdict true. There's one very specific thing that needs to be done here, where we expand this, add a margin, and add a non-zero constant to be the margin. If that's not done, then this result will not work correctly. That should be everything, so we'll save and close the VI. Now we'll open SoundCheck 15 and see what our VI looks like when we run it. We'll reopen the sequence that we wrote earlier. If we look in the memory list, you can see that the placeholders are already there. That's because we've already opened and run the editor VI. So now, when we run the sequence, it should populate these placeholders and give them actual data points. So we ran it, and now you can see that there's no longer placeholders, but are actually filled with data. And this is what we're expecting to see. If we look at the value, this should be 1, 2, 3. The result will be a pass. Now the waveform will be the ramp from 0 to 99, with 1 millisecond between each value.